So just signed in. I'm gonna go ahead and submit the solution that I had right here. X is not defined. Oh yeah, because I'm missing the const there. Small syntax. Issues. Nums. Alright, well. Make sure my assumptions was set is correct. I'm missing something here. I mean, this is simple enough that if it has it, it's added. And then it should continue to add. Yeah. It's mutable. So I don't need to reassign it. I'm not working with pure functional data structures. Although I wish we were. Yeah, I'm just gonna have to debug it from here. I mean, this isn't making any sense to me why it would be failing something as simple as this. So let's make sure it's actually looping through the number array as duplicate. Static. Alright, so it's looping through. Oh, it's okay. So it looks like it's actually looping through the indices instead of instead of iterating over each element of the array. So go ahead and change that. This could be nums, idx, nums IDX. I mean, if I was using JavaScript every day, that would be something that wouldn't necessarily run into. I need to get rid of the TypeScript annotation. Alright, so that's the answer. Oh, hit again, I thought it was next. Alright, so move on to the next one, right? Valid anagram. That should be the next one. I have to have the roadmap again. Roadmap. Yeah, anagram. So no. Okay, there. Updates. Keeps track of them. Okay. So given two strings S and T, return true if the two strings are anagrams of each other. Otherwise, return false. Anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Okay. This is, what I had in mind at first, just from previously working through problems like these, is that the anagram, oh no, that's a palindrome, I think. So like race car would be the exact same. Like you can't reorder the characters and the transformation, but for an anagram you can. Rearrange them in any way you would like. So, yeah, I would still think about, let's see, what is the time and space? So you should aim for a solution with n plus m time and O1 space, where n is the length of the string and m is the length of string m. M is the length of string S, and m is the length of string T. Okay. So can't use something to track shared characters between the two. With that O1 space complexity. I mean, I would just sort the characters and then iterate through the two. Well, I would, let's see, I can only iterate through both of them one time, or one of them one time. Index into the array, and, oh yeah, are both of the inputs going to be the same length? Because if they are, then I can use the for const, get the indice, index into both of them. Otherwise, if they aren't the same length, then you run the risk of introducing an out-of-bounds array error. The order of the characters, exact same characters of another string, given two strings. So it doesn't specify that the length of the two will always be the same. So I don't know if that's a safe assumption that I can make. I still think I'll just have to add a guard, but I'll still run with that. IDX for S for N. So C1, SIDX, and then the guard I'll have is if I think break will exit out of the loop entirely, because if this is the case, then they're definitely not anagrams, and we'll just want to go ahead and return early. So if t dot length, if IDX is less than t dot length minus 1, this is a guard to ensure no out of bounds array access attempts. Otherwise, we can go ahead and safely access the next character. And if, see, but before all this, I need to create a S2 where they are ordered. So let's see. Just search this up. JavaScript sort string. There should just be some method on it, like s.sort. That would be helpful if there was. If not, let's see, sort a string. There should, yeah, there's a method. Didn't pop up in the IntelliSense. All right. So use these sorted strings. All the characters should be in the correct order now. And then if C1 not equal to C2 is anagram, we can break. Again, breaking out early. Oh no, wait. Start with true, and then we'll just set it false here. Is anagram false, and then break. Alright. It looks good to me. Just want to make sure that the break works as I'm thinking it does. That we exit out of the loop as expected, just because, again, it's been some time that I've been working with JavaScript on a daily basis. Miss T there. It's not. Now IDX is a string. Like it's looping through every character now. I might just have to install nodes like just regular JavaScript. Or figure out how. Let's see. Can I opt out of TypeScript? Check module, check. Can I use types? Oh, yeah. Let's use a regular JS file. Solution. Was there an example? Grab that real quick. Car race. Make this static. Yeah, it's still complaining about the sort function. What is it? What? W3 schools? No, that wasn't it. This one. Geeks for Geeks. Converts the string to an array first, and then joins it. Alright, no other choice. Go ahead and create the sort. Alright, so yeah. Just go ahead and also test out. If I just omit one character from the second string so that I can ensure my break is being reached and nothing blows up. Now hold up. That, I mean, nothing is blowing up, but it should not be. Okay, yeah, I should set it to false. I did forget to do that. So breakout and is anagram is false. So now that should work. A.sort. It's complaining about that here too. Okay. So I don't know what was up with the Geeks for Geeks article, but sort is definitely not a function or method on string. So that is getting a different result. Did I? C2 is T2. I mean, it's failing a case that, oh, now it's returning false here. Oh, I meant to, okay. So yeah, it should be, if it's greater than, I got that mixed up. So yeah, different size strings are a possibility. When S is less than, I guess I didn't account for that, huh? Yeah, I only accounted for when S is greater than T in length. So yeah, go ahead and fix that, eh? Go ahead and make an early return. If S is less than A, or S's length is less than T's length. I mean, that should be good enough. Should handle all the other cases just fine. Alright. Keep accidentally submitting that twice. Okay. What we got? 2 sum. Yeah, I want to get to at least, I don't know, probably like 4 or 5 of these if possible for today. I'm not trying to do like an hour, 10-hour long stream. So 2 sum. Given an array of integers, nums, and an integer target, return the indices I and j such that nums I plus nums j equals target, and I isn't equal to j. You may assume every input has exactly one pair of indices, I and j, that satisfy the condition. So what's the recommended time and space complexity? Big O of n for time, big O of n for space, where n is the size of the input array. So that automatically limits, you can't use 2 loops in order to try and solve this. So, well, I mean like two nested loops. So constraint 2 must be less than the number's length, and then, or 2, and it's between 2 and 1,000. And then negative 10 million and greater than, so less than or equal to 10 million is the size of the numbers that can be added. JavaScript, number bounds, number min value, yeah, it should be good. Damn, I accidentally closed it. And the target is bound between those numbers as well. And if the two numbers need to add up to it, and I would think that this third constraint would need to be larger to accommodate potential of 2 numbers that could potentially be, I mean, you would think it would be 20 million for this, but whatever. So how to go about this? You can use up to big O of n space. So what data structure should I use here in order to track what we've got? Use I and j. 2 indices. What would that be? I'm thinking of a dictionary right now. Just because if there's no way to, because it'd be kind of difficult to track, or well, to loop through and have 2 different numbers that kind of say, for example, I starts at the end of the list and then J starts at the end. I mean, even if you were able to do that, given the time complexity constraint, I wouldn't necessarily be able to find which 2 indices which access the elements of the list would be able to add up to the target. So I'm thinking of having a dictionary where you would have a key. And it's going to have 2 levels to it. So what I'm thinking of is, you should be able to just use an integer as a key if I'm not mistaken. So for example, in this case, there'd be 3, and then it'll have all the other ones, and then the value that they add up to stored. Still not convinced that's exactly what you'll need. If you can only, because with the time complexity constraint, you can only loop through the list one time, or the array one time. So I starts at 3. In this case, 10 is the target, so I starts at 4. Yeah, I would say if you're going to end up breaking out of the loop as soon as, one of them is one of the pairs of numbers that add up to the target is found. But otherwise, I think that this dictionary, if you can use numbers as keys, would be an ideal solution. Close that. Equals. So yeah, it automatically converts it into a string. So that'll work. I should be able to, if I index in, yep. Yeah, so that's what I'm thinking of. Just loop through all of them. No, it's not quite. Because then I would still need to iterate through what I'm storing in the hash map as well. That adds another loop. It just ends up being 2n, and with big O complexity, you would typically end up dropping the constant anyway. So I think perhaps it could end up being still a feasible way of solving the problem. But I suppose I just want to consider any possible alternatives, although right now I'm not seeing any. Seems like store visited numbers and add subsequent numbers. We do have space in space. So max. Three, 4. I mean, even this hash map approach or whatever other representation I use just seems as though whatever approach I have in mind with, well, the approach that I have in mind with this would end up exceeding the the O, big O of n time or space complexity as well. Every input has exactly one pair of indices. Turn the answer with the smallest index first. Yeah, this representation wouldn't be sufficient because you need to store the index. Well, don't have any other ideas for what to do here, so I'll go ahead and just run with this representation. Um, mm, from the array. Nums. So yeah, we'll iterate through each one. I mean, yeah, if I have to iterate through the data structure, it's going to inevitably end up being, or the hash map, while I'm iterating through the nums array. It's already a nested loop. It definitely violates the time complexity. It's okay. This is what I'll ask. Like I said, when I started the stream, I've never really grinded Neetcode before or these type of problems. So, let's see. I'll just ask ChatGPT to explain to me the general algorithmic problem solving techniques. I'll provide an overview. Automatically, I wouldn't say divide and conquer is the solution. Greedy also uses some recursion and breaks things down into smaller problems. Backtracking. Backtracking is looking to be the most feasible one out of all the above. I could use recursion. Alright, so can you provide me with a problem rhythmic problem description without providing an answer that illustrates the kind of problems that backtracking algorithmic technique would be used on. The N-Queens puzzle. Automatically, I'm thinking of I and J here. The task is to place N-Queens on the board such that no two queens attack each other. Queens can attack other queens that are now in the same row, column, or diagonal. An integer n representing the size of the chessboard and the number of queens to place. And the output, that's the input. And then I guess it's like a tuple. I'm just rereading over this because it wouldn't make sense for it to just be a single integer to represent both of them, of course. Output, print all possible arrangements of n queens on the chessboard or indicate that no solution exists for the given n. N must be greater than or equal to 1. For each valid arrangement, output the positions of the queens, their row and column indices, or visualize the board with Q for queens and a period for empty spaces. So they can attack on the same row, column, or diagonal. All possible ways to place queens, pruning placements that violate the constraints. And backtracking when a configuration is invalid. So no two queens attack each other. And I've seen that one before. Sudoku solver. Given a partially filled 9x9 Sudoku grid, your task is to complete the grid by filling in the empty cells with digits 1 through 9, such that each row contains all digits from 1 to 9 exactly once. Each column contains all digits from 1 to 9 exactly once, and each 9x9 or 9 3x3 subgrids contain all digits from 1 to 9 exactly once. Never played Sudoku before. Trying digits in empty cells, checking for violations of the Sudoku rules, and backtracking when a conflict arises. See, what is the current best algorithmic solution to the Sudoku? Is that how you spell it? Sudoku? Sudoku problem and big O notation in regard to time complexity and space complexity. A worst case. Adding the constant here again. Space complexity and then far field backtracking steps due to the constraints of the game. Most practical solvers so backtracking. That might be something I have to look into. In any case, if I was to consider using recursion instead of a for loop, I go ahead and look at the time complexity graph, just because that's what's tripping me up. Because just the general rule is like, oh yeah, you drop constants. If I'm not mistaken, yeah, it's 2 raised to n and then n2. Okay, so something like the 9m time complexity from a Sudoku solver should still be considered O of n running time. Just thinking about, just trying to avoid these worst case scenarios here. So if you have a OJ times target. Different options on doing them. I don't necessarily think this would be the technique to. I mean, it's an easy problem, right? So, yeah, I don't think recursion really needed here. Mm, I mean, any way I think about it, it's like there's always going to need to be two loops to the array. It seems like it automatically just violates that recommended time and space complexity. If I'm not mistaken, I mean, yeah, for each one. So that would be this big O notation, or time complexity, if I'm not mistaken. If you have to have a loop and an inner loop. And then using this approach still requires looping through the hash map on each subsequent. So like you start out, you get 3 here, you add it, then on 4 you're gonna have to loop through all of the elements here in order to be able to even add. So like, say by the time you get to 5, you're gonna have 4 and 3 in here. You're gonna have to iterate through 4 and 3 to be able to even determine what the result of adding those two together are, and if they reach the target number. The only other thing I'm considering is thought that just popped up into my mind was if there's a possibility of numbers being in the array that are greater than the target number. You assume every input. I mean, it doesn't specify that. Then you could filter out all of those. I mean, that already uses up time complexity wise, big O of n time, to be able to filter all of those out. I mean, it's not specified as a constraint that the numbers in the array are always going to be less than the target number. So if you knew that there would possibly be, then that would at least help in shortening down the time to find two numbers that add up to the target number. I think I'm gonna have to do this and pick up again another day. I'm not gonna look into this at all. I'll just pick up from here, and I'm probably gonna still just end up going with this hash map, or maybe even some simpler, smaller one, but they're still going to require a loop through this data structure. I mean, it has to be tracked somehow. There's no way of just incrementing two numbers and being able to determine what the result is without using any kind of storage. So yeah, I'll run with this next time, pick up from there.